Hi, this is Mr. Judd, and this is a question. Do expensive painkillers work better than cheaper ones? Does cost really matter? In this video, we're going to take a look at an experiment that tests this question. Questions are important in science. They start you thinking in a scientific way. By the way, the original experiment based on this question was published in the Journal of the American Medical Association. Let's go. Now that we've established our question, it's time to move on to the hypothesis. A hypothesis is a prediction of what's going to happen in this experiment. Here's my prediction. If people take an expensive painkiller, then it will reduce more pain. I think the expensive painkiller is going to work better. I've made a prediction. I want you to notice that to help me, I've used an if to begin my hypothesis. Somewhere down the line, I used a then to talk about the result. It helps make sure that you're not asking a question, you're making a prediction. This if-then format might help later in figuring out the parts of the experiment too. Now that we've made our hypothesis, it's time to start setting up this experiment. We have a medical experiment, so we're going to make groups, and those groups are going to be test subjects. The first group is called the experimental group. I'm going to make another group called the control group. Both will have test subjects, and both will get a painkiller. So what's the difference? Well, the experimental group is going to be the one where we're actually testing our hypothesis. We are going to give them the more expensive medication. The control group basically answers the question, compared to what? We want to be able to compare to see if the expensive medication had any effect. So we're going to have to compare it to a cheaper medication. That's the experimental group and control group. Control groups are really important, otherwise you have an invalid experiment. You have nothing to compare the experimental group to. Now that we've set up our control group and our experimental group, it's time to talk about variables. And variables are the part of the experiment that often confuse my students. So let's work them out. Variables are pretty simple. They are just differences between our control group and our experimental group. So what are the differences? Well, at the very beginning, we set up a difference. We gave one of our groups an expensive medication and one a cheaper medication. So that one is called the independent variable. The independent variable is the one that I set up in the beginning of the experiment. I use that I as a little clue. So the independent variable here is the cost of the medication. That is the only thing that we should change between the two groups. So are there any other differences between the groups? Well, in our hypothesis, we predicted there would be a difference. At the end, we thought that there would be a difference in their pain, and that's called the dependent variable. So there might be, at the end, a difference in the amount of pain. And the D in dependent variable gives me a clue that this is the data, or the results. So at the beginning, we set up the independent variable, and at the end, we measure the dependent variable. All right, are there any other variables we need to talk about? Well, lots. There are what are called controlled variables, or things we don't want to change. So when you see this controlled, this means hopefully not variables or not differences. We don't want different age. We don't want different gender. We shouldn't change the amount of pain that they're in, etc. Everything should be fair between the two groups. Those things that are the same, and we need to keep the same, are called controlled variables, or we don't want them to be variables. Now it's time for the big reveal, the results. At the end of this experiment, 85% of the test subjects that got the more expensive medication had reduced pain, while only 61% that got the cheaper medication. So how do we state our results? We win, we're the best, it worked. Well, scientists usually try to err on the side of caution. And so what we'll say is that data supports our hypothesis. If more data comes along, we might be able to change our mind or even reinforce this result. But there's an interesting postscript to this experiment. And that is the experimenters were actually playing a trick. In this experiment, both medications were not painkillers at all. They were instead what's called a placebo. A placebo is a fake medication, usually just a sugar pill. It doesn't do anything. The only real independent variable between our groups is what they thought the cost of the medication was. So think about that. the reduction in pain that the experimental group saw was all in their head. In medical experiments, it's important to know about the placebo effect, that if a test subject thinks they're getting something that will help, it may actually help because it's all in their head. Placebos are often used as a good control group when we're testing a new medication because they're a basis of comparison. Both test groups think they're getting something that will help, so that would be a controlled variable. Let's talk about validity now. Validity means that the experiment was fair and the results are reliable. So, how do we increase our validity? Well, if our sample size, our numbers of test subjects are higher, the validity will be better. We'll have more faith in our results. Also, if you are able to control more variables and make sure that it's a fair comparison, that you're only testing your independent variable, then your validity will improve. Also, if you do the experiment more and more times, that's called replicating the experiment, and the result comes out the same each time, you will also have greater validity.